see some more examples depending on velocity and acceleration. So it is our first example of today. If the radial and transverse velocities of a particle are proportional to each other, and also the radial and transverse accelerations are always proportional to each other, so we have to show this result. So here it is radial velocity, transverse velocity, radial acceleration and transverse acceleration, and we have given these two results. So radial velocity proportional to transverse velocity, so r dot proportional to r theta dot, so r dot will be some constant into r theta dot. So here we'll get, according to last problem, r will be equal to c e to power k theta, where k is a constant. And also we have given radial acceleration proportional to transverse acceleration. So this is radial acceleration proportional to transverse acceleration. So proportionality को हटा करके लिख रहे हैं यहाँ पर lambda, where lambda is some constant. Now on the left side, theta dot की वैल्यू यहाँ से निकाल रहे हैं, r dot upon kr सब्स्टिट्यूट करना है. Here also पूरा सिंप्लीफाई करते हैं, रिजल्ट आएगा r डबल डॉट 1 माइनस लेमड़ा k इक्वल टू r dot square upon r lambda by k plus 1 upon k square, and from here we'll get value of r double dot. Now this much quantity is constant here, so let us take it a. So r double dot upon r dot, ये यहाँ से एक r dot को डिनोमिनेटर में ला रहे हैं, इक्वल टू a r dot upon r, or we can write dy dt of r dot upon r dot equal to a dy dt of r upon vector r. Just integrate. So left side will log of r dot a log of r plus log of b, and from here we'll get r dot will be equal to b r to power a. Just a यहाँ power में आएगा, and log a plus log b, it is log of a into b, so we'll get this result. Now resultant velocity of the particle, velocity के दो component है, under root of square. Now let us substitute here value of r theta dot, that is r dot square upon k square. r dot square common, root के बाहर लाएंगे r dot is 1 plus 1 upon k square. Now r dot outside लाया अपन ने, so here it is, actually it is under root here equal to this. Now take here this much quantity is constant here, और r dot को replace करना है by br to power a. So here this much quantity is constant here, also b is constant, so we can write result velocity of the particle is proportional to ath power of r, that is velocity of the particle varies as some power of radius vector. Now next example, if the path of a moving particle is an equiangular spiral, it is equation of equiangular spiral, and the radius vector to the particle has constant angular velocity, so that the resultant acceleration of the particle makes an angle 2 alpha with the radius vector and is of magnitude v square by r, where v is the speed of particle. So it is our equation of path. Also we have given here that the particle has constant angular velocity, that is theta dot, it is constant, that is omega support. Now differentiate number 1, it is r dot a to power theta cot alpha की फर्दर डेरिवेटिव cot alpha is constant, that is theta dot, ये आ जाएगा r omega cot alpha, r double dot निकालना है, it is radial acceleration, and also we can find transverse acceleration. Now speed, it is nothing but magnitude of velocity under root of this, यहाँ vr और v theta की वैल्यू रखना है, and let us simplify this. इसको जब सिंप्लीफाई करोगे 1 प्लस कॉट स्क्वायर अल्फा, इट इज कोसेक स्क्वायर अल्फा, ये हो जाएगा आर ओमेगा कोसेक अल्फा, एंड रिजल्टेंट एक्सेलरेशन इट इज अंडर रूट ऑफ ए आर स्क्वायर प्लस ए थीटा स्क्वायर, दैट इज आर ओमेगा स्क्वायर कॉट स्क्वायर अल्फा माइनस 1 स्क्वायर प्लस ट्वाइस आर ओमेगा स्क्वायर कॉट अल्फा स्क्वायर, एंड सिंप्लीफाई दिस होल, तो रिजल्ट आएगा आर स्क्वायर ओमेगा टू पावर 4 कोसेक टू पावर 4 अल्फा, that is r omega square cosec square alpha, or we can write in this way, r omega cosec alpha square upon r. r से एक्चुअली इसको ऊपर नीचे डिवाइड किए अपन ने. So it is v square by r. Suppose the resultant acceleration of a particle makes an angle phi with the radius vector. So tan phi is given by a theta by ar. A theta और ar की वैल्यू रखना है. Here r will get cancelled, here omega square cancel. So it is twice cot alpha upon cot square alpha minus 1. पूरा सिंप्लीफाई करो इसको तो रिजल्ट आता है साइन स्क्वायर अल्फा अपॉन कॉस स्क्वायर अल्फा माइनस साइन स्क्वायर अल्फा, और वी कैन राइट it is twice sin alpha cos alpha upon cos square alpha minus sin square alpha. It is sin 2 alpha by cos 2 alpha, that is tan 2 alpha. So phi will be equal to 2 alpha, that is the resultant acceleration of the particle makes an angle 2 alpha with the radius vector. Then next example, an insect crawl at a constant rate u along the spoke of a cart wheel of radius a. The cart is moving with velocity v. Find the acceleration along and perpendicular to spoke. So O be the center of a cart here of radius a, and OA, it is suppose spoke along which an insect crawl with a constant rate u. So let OP is here r. So r dot is u here, aerial velocity. So r will be ut just by integrating. So cart is moving with constant velocity. So a theta will be v, transverse velocity. So r dot equal to u. R double dot, it is 0 since u is constant. And a theta dot will be v. So theta dot will be equal to 0. Now the acceleration along the spoke. So clearly it is radial acceleration, is this, and acceleration perpendicular to spoke, you can solve this, that is transverse acceleration. It is given by this result. And next is a small bit slide with constant speed v on a smooth wire in a shape of cardioid. So that the value of d theta by dt is this, and the radial component is constant. So the path of bit is this here, r dot निकालना है, r double dot, स्पीड निकाल सकते हैं बीट की, सब वैल्यू सब्स्टिट्यूट करना है. But given that the speed of bit is v, so this much quantity is v here. From here we can find theta dot. So result आ रहा है v by twice a sec theta by 2. And radial acceleration r double dot is given by this formula. R double dot की वैल्यू रखना है, and also r theta dot square. पूरा सिंप्लीफाई करो, and after simplification you will get here our result, that is minus 3 by 2 v square by 4a sec square theta by 2 twice cos square theta by 2. So it is our radial acceleration of the bit. So friends, let me stop here now. Stay home, stay safe. Thank you.